So in the previous lecture, we had seen the logic families. We have seen the different types of logic families, their characteristics. So based on these characteristics, now we have to compare these logic families. Then we'll go to the next chapter. So here comparison of TTL, CMOS and ECL is shown. So we have seen the characteristics. So those characteristics will come in the parameters. So the basic gate used are, for TTL it is NAND gate, for CMOS it is NAND NOR gate, and for ECL it is OR NOR. Fan out. As we have seen, fan out is the number of gates which can be connected to at the output of a gate. So your TTL can drive, the TTL gate can drive 10 similar logic gates. So fan out is 10, and for CMOS it is 50, for ECL it is 25. So fan out of CMOS is high, more, which is the advantage of CMOS. Then propagation delay. So this delay, it should be low as possible. So for TTL it is 10 nanoseconds, for CMOS it is 105 nanoseconds, and for ECL it is 2 nanoseconds. So this delay is very low in ECL. So that is the advantage of ECL. So it is the fastest of all the logic families. Then the noise margin. The noise margin, it is the difference between the voltage levels is made, which is called as a noise margin. So that is low in ECL, then moderate in TTL, and high in CMOS. So this shows that the noise immunity is low in ECL. Then comes a power dissipation. So as we have seen, maximum power dissipated, the more that IC gets power gets dissipated, the more the IC will get heated. So here the power dissipation is more in ECL, that is 40 to 50 milliwatts, and it is very low in CMOS, which is 0.1 milliwatts. So that is the advantage of this CMOS, and it is 10 milliwatts in TTL. So when the comparison is asked, you have to write these numerical values of these parameters and not as high, low. Then noise immunity, as we had seen noise margin just now, same it is connected to this. Noise immunity is connected to this noise margin. So noise immunity is good in ECL, very good in TTL, and excellent in CMOS. Means the ability to avoid this noise is good in CMOS. It is very good in CMOS. Devices used. So the internally to form this IC, in TTL, transistor, diode, resistors are used. For CMOS, P and N channel MOSFET is used, and for ECL, transistor and resistor are used. Switching speed. So as I have said, in propagation delay, the propagation delay is very less in ECL, so it is the fastest one. So switching speed, fastest in ECL, faster in TTL, and then it is in speed, CMOS is very slower. So that is its disadvantage. Fan in, 12 to 14 in TTL, which is its advantage. TTL greater than 10 in CMOS and ECL. Then speed, power product, it is 100 picojoules in TTL, 0.7 picojoules in CMOS, and in ECL it is 40 to 100 picojoules. So by seeing this comparison, we can find out the advantage and disadvantages of these logic families. So the parameters which have not just explained, so they are given in this comparison, and here only TTL and CMOS is compared. So here the voltage parameters are given and the power supply required and the component density. So the voltages, as there is a range for low level input, high level input, and same for low level output and high level output. So that range is given here. For TTL, the input low level maximum voltage VIL max is 0.8 and the input high level minimum voltage is 2 volts. So high level means logic 1 level, the minimum voltage starts from 2 volts to 5 volts, that is the range. And for CMOS, the low level input voltage, the maximum limit is 1.5 volts, means it starts from 0 to 1.5. Whereas for the input high level, it is the minimum value is 3.5, means it starts from 3.5 to 5 or more voltage. Then the output low level maximum value is 0.4 for TTL and 0.05 volts for CMOS. VOH minimum, it is 2.7 volts for TTL and 4.95 volts for CMOS. So these are the voltage parameters of TTL and CMOS. Power supply voltage means to use this IC, TTL IC, we will require fixed voltage of 5 volts, whereas for CMOS we will require 3 to 15 volts, so it is variable. Component density or packaging density means on the same size we can have more CMOS devices, means P channel, N channel MOSFETs, we can use more in the same size, whereas for TTL, as the size is bigger than CMOS, less is the component density. Then we'll see the advantages of TTL. As I had said, in the comparison itself, we'll get the advantages and disadvantages. So only I have written here about the TTL. We'll see the advantages of TTL and disadvantages. The remaining advantage and disadvantage of CMOS, you can write it by seeing the comparison. So advantages, it is most rugged, means less susceptible to electrical damage. It has strong drive capability. As we had seen, its fan out is 10 and fan in is 12 to 14. It is faster in some versions. TTL requires one supply voltage, that is the advantage. It has noise immunity which is better than ECL, but it is less than CMOS. It has power per gate is less, about 1 to 22 milliwatts, which is between the CMOS and ECL. Low propagation delay, power dissipation is independent of frequency, and it is compatible to all other logic families. So these are the advantages. Next is the disadvantages. Power dissipation is more as compared to the CMOS family. Fan out is 10, which is less as compared to CMOS. So CMOS requires the fan out is high. Fan out of CMOS is high, that is 50, around 50. but here it is 10. So that is a disadvantage if we compare with CMOS. Less packaging density, so the number of components on the same chip, we can use less components. Poor noise immunity and operates only on 5 volts. So these are the disadvantages. So similarly you can also write the advantage and disadvantage for CMOS IC. So for you only you have to see the comparison of these three logic families and the characteristics and the classification. So detailed circuit description is not there for you. So this completes our first chapter. Now we have to go to the second chapter or the unit, which is for the name of the unit is combinational logic circuits, and it is for 14 marks. So after studying this topic, you will be able to represent any logic expression in SOP and POS forms. You will be able to understand standard and canonical forms of SOP and POS. You will be able to convert these equations in canonical form. You will be able to minimize this logic function using K-map and design half adder, half subtractor, multiplexer and demultiplexer. So these all are combinational logic circuits. So in this chapter we are going to see all these topics. So first we'll see what is combinational circuit. So the digital system, it is classified into two categories, that is a combinational logic circuit and sequential logic circuit. So in this chapter we are going to see the combinational circuits, and in the next chapter sequential logic circuits. So the comparison it will be easier when you study these both. So we'll not compare it just now. We'll start with the combinational circuit. So combinational circuit, it is a circuit in which the output, it depends only on the inputs which are present at that instant. So here the output, it does not depend on the past input or output. So this circuit does not require any memory. The examples of this combinational circuit is adder, subtractor, encoder, decoder, multiplexer, demultiplexer and so on. So here as shown in the figure, block diagram is shown of the combinational circuit which is having n number of inputs and m number of outputs. So this output, it depends only on the inputs which are applied at that instant and not the previous inputs. Now we have to see how to design, what are the requirements to design the combinational circuit. So to design the circuit, we will require the Boolean expression, the truth table regarding this expression and the set of statements. So after having these all requirements, then we can design the combinational circuit. So starting with the combinational circuit design, first we have to see how to represent the expressions. So we have seen the method, Boolean algebra method, to minimize the Boolean expression. So there are other methods also, like Karnoff map method, Quinn-McCluskey method, variable entered mapping technique. So out of this you have to see Karnoff map method in this topic. There are two forms of logical expression. So up till now we have seen only the logical expression. We have written the expression, but how its types we have to see Now its types. So it is represented in SOP form, which is called as sum of product form or product of sum form. So we'll see what is this SOP form. So SOP, representation of logic expressions. So in SOP expression, two or more product terms. Wait a bit, let me take the pen. So this is our SOP expression. So in this, ABC is a product term, CDF, BC, B bar, CD, these are the product terms. So there are, in this way, there are two or more product terms and they are summed by the using the Boolean operator, that is plus sign. So the product terms are summed by using plus sign. So in this SOP form, these A, B, C, these are called as variables or literals, and these variables, so here A, B, C, so there may be any number of variables and these are called as variables or literals. So these variables, it may be in the complemented or uncomplemented form. So here the example is shown, and these complemented, only each variable is complemented and not both two variables or three variables. So here the example is shown, A bar, B bar, C bar. So this is the right SOP and the wrong one is A, B, C whole bar. So we cannot use this whole bar in sum of the product form. So whatever we have written, used the expressions up till now, they were in the SOP form. Next is the product of sum. So P means product of, S means sum. So in this product of POS form, see the expression. So in the brackets, so this in the brackets, each variable is summed. So these are called as sum terms. A, like A plus B bar plus C. A bar plus B is the second term. See here, B plus C plus D bar is a separate term. So these are called as the sum terms, as each variable is sum, is ORed with the other, and these variables may be in complemented or uncomplemented form, and these sum terms, they are ANDed with each other. So the name comes as product. We are taking the product of these sum terms. So here each terms are ANDed, so a dot is used within this each terms. So your expression in POS form will be, for example, as A plus B bar bracket, in another bracket we will write A plus C, A bar plus C, and so on. So these equations are called as POS form. So the expressions which we had seen just now, they are represented in SOP and POS form. So these all are called as standard representation or standard SOP form or standard POS form. In standard SOP form, the equations are written as an OR of AND terms. Means the terms are ANDed. The terms, in the terms, within the terms, the variables are ANDed, and these ANDed terms are again ORed by using plus sign. So here the example, these, see here, the examples given here as AB plus C in one bracket and A plus C in the another bracket. So here each variable should be there. So here A into B has been written here. So this cannot be in POS form. In the second example, AC in bracket A plus B is written. So this is not also in the SOP form. So these are called as mixed form. So we have to convert these equations into SOP or POS form if it is given, and then we have to use these expressions. So in standard form, each expression may contain one or two or any number of input variables. Like, see here, this term, it is having three variables as A, B, C, and the last term is having only one variable as B. So the standard form may have a single or n number of variables in each term. So each term may contain one or many variables. Same is for POS form also. Then we'll see the canonical SOP and POS form. So just now we had seen SOP and POS form, the standard SOP and POS form. Now we have to see what is canonical SOP form. So canonical means each term is having all the variables. Like if there are two variables, then each term, for example AB plus A bar B. So these are the separate terms and these are having two variables A and B. So this is called as canonical SOP. But standard SOP we can write as A plus A bar B. So if the SOP form is given as A plus A bar B, so this is called as standard SOP, and the upper one is called as canonical SOP. So see what is written here. This rule states that each term in equation must contain all the available input variables in complemented or uncomplemented form. So the example of canonical SOP is given as y is equal to ABC plus A B bar C bar plus A bar BC. So each term is having all the three variables as A, B, C, and these variables may be in either complemented or uncomplemented form. See the example of POS form. Each term, now here there are some term A plus B plus C. In the second term it is written A plus B bar plus C. Third term A bar plus B bar plus C. So each term is having all the three variables, that is A, B, C. So this is called as canonical form. Now we'll see how to convert the standard SOP form into canonical SOP form. So see what are the steps. First, for each product term, find the missing variable. So first we have to find which variable is missing in that term. Then second is AND term with the term formed by ORing missing variable and its complement. So we'll see the example. So the equation is given as y is equal to AB plus AC bar plus BC. Now see here each term. In each term one variable is missing. So in some terms C is present, or B is present, or A is present. So see the first term. First term has A dot B. So C is absent. So C is the missing variable. Second is A C bar. So A and C are present. So B is absent. So B is a missing variable. And in the third, B and C is there. A is missing. So what we have to do first is to find out the missing variable. And then now we have to AND or this missing variable with its complement. For example, if the C variable is absent in the first one, we have to write C plus C bar. So we have to OR that missing variable with its complement, and then we have to AND with the first term. So here how it is written, see, AB into, in the bracket, C plus C bar. So in the second, A C bar is the term, product term, A C bar, and the missing is B. So we have ANDed with B plus B bar. In the third one, BC is the product term, and we have the missing variable is A. So we have ANDed with A plus A bar. So now to get the equation in the canonical form, you have to use the distributive law here. So open the brackets. So see this step, how it is written, ABC plus ABC bar. Again, so open the brackets and write in this way. Now in the further step, you have to change the sequence. Now for example, in this BC A bar, so A is at the third position, so you have to write as A bar BC. So after writing this, in the next step you have to take the same terms at the side. So rearrange these terms like ABC plus ABC. So these are the like terms, similar terms, and so on. And in the last step, as we know, A plus A is nothing but A. So we have to reduce this 2 in only, you have to write only one time. So in the last equation, it is written as ABC plus ABC bar. So instead of these 2 ABC bar, we have written it only once. So the last equation is having all the 3 variables. See, what was our question? It was AB plus AC bar plus BC, where the variables were missing. And see the last equation. Now each term is having all the 3 variables. So the last equation is called as canonical SOP. So this is the way how we have converted the standard SOP into canonical SOP. So first, I'll again repeat, first is you have to find which variable is missing, and then second step is you have to AND the term, each term with the ORing of the missing and its complement. For example, suppose AB. So in this AB, C is missing. So you have to multiply or AND with C plus C bar. And now do the further steps to get the last equation. So next is how to convert the standard POS into canonical POS. So standard POS means one or two variables may be missing in the terms, in the sum terms. So POS means there are some terms like A plus B in one bracket, in the another bracket B plus C, and so on. So these are called as sum terms, and these two terms are ANDed with each other. So this is called as standard POS form. Now we have to convert into canonical POS form. Canonical means each term is having all the variables. See in here, in the second term C is present, whereas in the first term C is absent, and in the second term A is absent. So we have to first find out the missing variable, and now we have to OR. Like take the first term A plus B, you have to OR with the missing variable, that is C, and its complement. So you have to take the product of the missing and its variable, and you have to OR with the first term, and so on. So we will see this example. So the example given is A plus B in the bracket, second bracket A plus C, and third bracket B plus C bar. So first is here missing variable in the first is A plus B is given, so C is missing. Second term A plus C, B is missing. In the third term B plus C bar is given, so A is missing. Now you have to write the missing term and its complement, that is if C is there, C into C bar. Now see how it is written here. Take the first term as it is, A plus B. Now OR, so plus C into C bar is written. So in this way write for the remaining terms also. Now we know the expression as A plus BC is nothing but A plus B into A plus C. So use the same equation and convert the given equations. So it is written as, now see the first term, we have A plus B plus C, C bar. So how you will write? A plus C in one bracket, in the second bracket you will write A plus B plus C bar. So write the remaining brackets accordingly. Now the remaining steps are same. First rearrange the variables in A, B, C form, and then take the like terms together, and then again reduce and write only the single term instead of 2 or 3 like terms. So the last canonical POS form is given, which is having each sum terms, and they are having all the 3 variables, that is A, B and C. So up till now we have seen what is combinational circuit. Then for designing the combinational circuit we have to know the expression. So we have seen the different types of expressions, that is SOP and POS, the standard, their standard form and their canonical form, and how to convert this standard into canonical form. So one exercise has been given here, so try this to convert into one form into another form, standard SOP to canonical SOP. Thank you.